Today, on the notebook, multiplying binomials. The term binomials comes from two names, and it helps us remember that for binomials. There are two terms. When multiplying binomials, you will come across four main situations. Both binomials are different. The binomials are the same, and the terms are added. The binomials are the same, and the terms subtracted. The binomials are one of each, addition and subtraction. Now let's explore the methods used for each situation. When multiplying binomials, if you don't recognize a pattern, there is a method that always works, even for our special cases. If all else fails, FOIL. FOIL helps you remember the steps to multiply binomials. First, outsides, insides, lasts. There are three special cases to watch for when multiplying binomials. They are magical figures that transform complicated problems into recognizable patterns. The three magic binomials are the same binomial with addition, the same binomial with subtraction. The numbers are the same, but the signs are one of each. When multiplying the same binomial times itself, we begin with a perfect square. Let's look at what happens when we FOIL a perfect square with addition. First, x times x. Outsides, x times h, which is xh. Insides, x times h, which is xh. Lasts, h times h. So the last term is h squared. To put that all together, we have 1 x squared, 2 of x times h, and 1 h squared. If you see two of the same thing multiplied together, that is a perfect square. If you see a perfect square binomial with addition, the pattern is always x squared plus 2 xh plus h squared. Again, we are multiplying the same binomial times itself, so we have created another perfect square. Let's look at what happens when we FOIL a perfect square with subtraction. First, x times x. Outsides, x times negative h, which is negative xh. Insides, negative x times h, which is negative xh. Lasts, negative h times negative h. Remember negative times. Negative is positive, so the last term is h squared. To put that all together, we have 1 x squared, 2 of negative x times h, and 1 positive h squared. Because those negative h's multiply to make a positive, if you see two of the same binomials multiplied together and their sign is negative, the pattern is always x squared minus 2 xh plus h squared. When multiplying binomials that have the same numbers but opposite signs in the middle, we do not begin with a perfect square. Let's look at what happens when we FOIL binomials that only differ by opposite signs. First, x times x, which is x squared. Outsides, x times negative h, which is negative xh. Insides, x times h, which is xh. Lasts, h times negative h. Remember, positive times negative is negative. So the last term is negative h squared. Notice we have negative xh and positive xh. The reason binomials with the same numbers but opposite signs are so special is that the insides and outsides are opposites that cancel each other out. That takes us down to only two terms, x squared minus h squared. When multiplying binomials with the same numbers but opposite signs, the pattern is always x squared minus h squared. In the last two methods, we begin with one perfect square, or two of the same thing, and expand it. Here we begin with two different binomials, and end with two perfect squares that subtract. That is called a difference of squares. Let's take a moment to pause, check our notebook, and take a quick break.
Now we got Dylan in the elevator, distortion at the farmer's market.
Welcome back. Let's recap. When multiplying binomials, you can always FOIL. It will lead you down the right path, but it is long. There are three special cases of multiplying binomials, with magical shortcuts that remove roadblocks and clear the way toward a solution. We have our two perfect squares, multiplying the same binomial times itself, x plus h times x plus h, and x minus h times x minus h. These two have almost exactly the same pattern, with one sign they are different, the sign of the second term. An x squared a term either positive or negative with two copies of x times h and an h squared. That's the pattern every time. Just plug in the numbers. And our lucky four-leaf clover, multiplying binomials with the same numbers but different signs. When you have one of each sign, the middle terms cancel each other out. That takes us from 4 terms down to just 2 terms. It rarely gets more magical than that. Just remember, when multiplying magic binomials, positive is positive, negative is negative, and one of each is my 4 leaves. Let's look at some examples. Multiplying two different binomials, x plus 7 times w plus 6. For this situation, there is no special case. We must simply do what always works. FOIL, firsts, x times w, outsides, x times 6, insides, 7 times w, and lasts, 7 times 6, which is 42. We can combine our like terms. Remember, like terms are those with the exact same letters and the exact same degree, which for this example, there are no like terms. The final answer is xw plus 6, x plus 7, w plus 42. Note that the final answer is 4 terms. Using FOIL will always work for multiplying binomials, but it can take a long time or lead to careless mistakes. Now let's look at our two perfect squares in action. X plus 7 times x plus 7. Well, if we use our formula, we have the two values x for the first thing and 7 for the second. So the formula is the first thing squared, then 2 copies of the first and second things multiplied together, and finally the second thing squared, which is 49. And this is positive, so that sign between the first and second terms is positive. What happens if we change the two pluses to minuses? Remember, the only difference in our two perfect squares was the sign in front of that second term. X minus 7 times x minus 7. If we use our formula, we have the two values. The first value is x once more, but now the second value is negative 7. Let's use the formula. First thing squared, which is x squared. Then 2 copies of the first and second things multiplied together, which is 2 times negative 7x, and we can simplify that to negative 14x. And finally, the second value was minus 7. If we square negative 7, that is negative 7 times negative 7. Negative times negative is positive, so positive 49. Notice, these binomials have a negative, and the expansion also has a negative sign between the first and second terms. And finally, what if we have one of each? The 4-leaf clover. If you find it, you are a lucky bot. Well, this is the one where the answer is two perfect squares. The first thing squared minus the second thing squared. The first thing is x, the second thing is 7. So x squared minus 49. Boom, done. Multiplying a binomial by a binomial with the opposite sign is called multiplying by the conjugate. A conjugate is a special partner binomial that we can use to help ourselves in tricky situations. Caution! Resist the urge to make a common mistake that humans make. Because there is this pesky plus sign, you cannot just simply distribute exponents across terms. A lot of students want the perfect squares to equal a sum or difference of squares. But keep it straight. The difference of squares is not for perfect squares. The difference of squares is for conjugates, one of each sign with the same numbers. Our magic four-leaf clover. Perfect squares are not rare. They are critical and they do not give you the magical difference of squares. Review the four methods until they are memorized. Binomials are part of the heart of algebra, and you will need to use them often. See you next time on The Notebook.